So, the Monroe Mechanical Calculator has been proven to be quite a challenge. It's gotten probably more jammed than when I originally got it. When I originally got it, it would kind of oscillate back and forth very rapidly between, I think, addition and subtraction. And once I got it cleaned up, it sort of worked. Occasionally you'd get these guys to turn, and then it would clear, but it would also jam sometimes. And you hit addition and it would go in the correct direction, subtraction go in the correct direction. I'm doing it all hand cranking, by the way. I still don't have the motor system set up. But unfortunately it's gotten more and more kind of jammed and troubled, and I have been able to quite figure out why. And I've had a couple springs come loose when I've been poking and prodding around with like these little guys, or maybe they were loose, but I've been able to put those all back on until I discovered, surprise, let's see if I can find that little spring here. This little tiny spring that's in this file. I don't know if you can see it. I don't know if I want to take it out and lose it. It's a little bitty spring. And one thing I've kind of learned is a lot of these mechanisms, they don't do a particular thing directly. They're intermediary actions where they'll latch something. For instance, you push the addition button, and it doesn't just immediately cause the mechanism to do an addition. It sets a latch mechanism, and then that acts as kind of a memory, or like a bit variable, like in computers programming. And then as a result, you can lift up on the button and it won't just immediately just stop and forget about the function. It'll continue to do the function, and then the machine itself will clear this latch that kept the machine in that state, in this case addition or subtraction. I haven't even begun to worry about multiplication and division, and my concern is, of course, it could be like a multiplication or division mechanism is actually causing a lot of this jamming, because it seems like that's a real possibility. So what I've done is, initially I was trying to kind of look at the what prints were available for machines of the nearest age and design, and doing it on a tablet, and it's really tough to do. So I went through some trouble to print. In this case, this is the print for the, I believe it's the N6 model, this is printed in originally 1959, I believe. And it's pretty close. Once again, you can tell that a lot of this stuff is a carryover from the previous machine. So a lot of these things, like this bracket, this arm, parts here, a lot of these things are the same thing in here. And I've just been kind of methodically running through all this stuff, and then finding stuff that isn't on there, like this guy. He's obviously some of these other bits are for the more advanced, bigger machine which is the N6 or 6N. But a lot of this stuff is common to my machine, so I'm hoping I can find this mystery spring wherever it's at and put it back in place, and also kind of understand once again what's going on with this thing. So more of this searching around. On I go with that, I guess, next. Okay, here's the little problem guy. I have this little tiny mechanism, this little latch here, and this is, I'm pretty darn sure at this point where that missing spring is supposed to go. There's a hook back here, which is, can't really get on the camera, but at least I can show the front hook, and I guess I can show the drawing. And this is probably about the best view I can get. I mean, I've tried to put the camera in various locations because I can barely get my own eyeball view of this guy, let alone look at the thing and get the camera view. So that's basically it right there. Here's the spring I'm missing, or it's fallen off, and I have that little glass bottle, and it hooks to here and here, and it does this latching mechanism. So I'm still kind of struggling with the machine jumping back and forth between addition and subtraction, and I think I'm finally narrowing it down to the likely cause. The Monroe calculator, if you look at all the stuff when it's done correctly and it's normal and has been messed with, they tend to have really good termination as to how their springs are mounted. For instance, you'll have a nice good hook here, or you'll have a nice pin. I guess you can't see it from this pin here. It'll be hooked on a loop here, or a pin with notches. What's odd about this guy is this spring is strung all the way over here to a really long screw. And I discovered this thing early on. This spring was off, and I couldn't figure out where it could have gone other than this really long screw, which is in itself very uncharacteristic. Let's see if I can move the camera a bit closer, and actually what I can do is tilt it up here. So what you have here is this very uncharacteristic for them, because they usually make they appear to make their spring or their screws no longer than really necessary. This screw is a lot longer necessary, and my assumption was that this spring had to go on here because there's just nothing else here for this spring to go onto. But it would be held on by the threads and would just come off like it had before. So my suspicion is that there used to be a proper termination here, and I think what I'll do is I'll show what that normally would look like. So if we go over to the prints over here, and we go to this print here, what they'll have sometimes is this nice termination where, you know, in this case it has this nice little ring that would go on a shaft. But this guy goes on either a shaft or maybe a screw or something like that. But you can see how it has this nice hole and a slot. So I think you can, kind of like a picture frame hanger that mounts to like a nail on a wall. You can put the head of the nail through and then slide it down, and then you're just on the shaft, and it's held in there very securely. And so my suspicion is, a long time ago, perhaps, that part got lost for some reason, and they just stuck it. The screw is probably long on purpose. They might have had a nut on there, and the idea was that you had this longer little, I think they call it a, it's not a reference here, it's like a, kind of like a, let's see, what would it be? Well, I guess they call it a terminal. Okay, it's just like a terminal for electrical connections to like a loop connector to a screw binding post, something like that. And so losing that part, which added, if it's anything like the other thing, maybe a ½ inch or so, you wind up with the spring much too taut. And so I think I'll show next, I'll move the calculator around here, and I will show what I think I'm fighting against here. So with that spring in place, it too long, it puts too much tension on this guy, and you can see that arm moving back and forth. This arm, this end of the arm, which of course you can't see, is buried in there, is the on-off switch, and it would explain why this thing persistently only wants to stay on, never wants to stop. This spring is applying too much force, and it's always closing that switch just barely. And then the other thing that is very key is, and that's the problem here, is getting this guy in well enough to see these little details. And unfortunately, I need to be able to tilt this up just a little bit more. I have to admit, this all thread and everything's actually proving kind of handy for I certainly hadn't planned on it, but it's actually proven very nicely. So this feature here, there's a little indent in here, and that controls the clutch arm location. And if you have just a little too much spring force, I let go of the spring, pull it back a little bit more or loosen it, that stud doesn't quite go into this little notch. And I think the thing would be to, I'll do a little close-up of that one of those prints I have. But basically, right now what it does is when you're in, let's see here, I think addition is this one. Okay, so I clicked it to addition. And now this arm sits in this position, and it will rotate the intermediary. I guess actually it's the divided split gears that you key off your buttons from, and rotate that into your carriage by the intermediary gears and so forth. Still getting the lingo down. And then when it's all done, it'll sequence itself back to neutral. But what happens here is you can see it just popped very easily over to and popped a bit back again. Because the problem is this spring is applying too much force, and it's not allowing it to sit reasonably well. So if I loosen up on that spring, I think there's another spring that actually works this guy, and these two kind of add and subtract a little bit of force. So now with my pulling up on this spring that also for that arm that pushes on this arm on the other side, because this is a long arm, this one arm here for this guy has these little notches in here, and then also goes all the way to the end where the start-stop switch is. So it's a very key control element. And so with a little bit too much spring force, this thing just cannot seat well in that little depression there. But with that excess spring force removed, it snaps in there really quite positively. And I think, you know, with the canceling mechanism still being kind of tight and bindy, there's too much vibration and force going on here, and the machine bounces past, something goes off in the other direction. So I think the thought here is, and here I'll let go of that little arm down here that has that spring, and now the spring is applying too much force. So my guess is if I put some sort of equivalent of their little terminal loop feature that would reduce the length of that spring by about, I don't know, half an inch, and it still provides the necessary force, because this spring also, or this mechanism also does another, I think it does some other function too. Maybe it doesn't. I think it might do something else. It might be that it just needs this little compound. I guess I'm not even showing. I need this little bit of compounding action for those two, and for some reason, I guess that's how they chose the spring geometry. So sometimes figuring out why and how they're doing spring geometry is a bit of a mystery. But I guess you can't use a spring directly on this arm. The spring geometries just wouldn't work. But in this case, it works. Obviously, it works pretty well for their intended purpose. So if I take and put a little less tension on that spring by adding a little length of structure so that it's not so taut, that might solve a lot of my troubles. So that's what I think I'm going to do next. Let's see if that gets me somewheres here. So I made this little homemade terminal that adds about a half inch to it, because if you look at the drawings, a lot of the terminals that are in there seem to be about this length if I'm just gauging the scale right. So, and it looks like the terminals are designed kind of like a picture frame holder, and it hooks in past there and it's held in place. And then with that, I now have the correct tensioning on this guy, which then works this arm here that ultimately closes and opens this start-stop switch. And the machine would never stop. It kept going. You could not get it to stop and clear its cycle. You just run. And it would sometimes bounce back and forth between modes. And this arm also, this spring also works this arm. It goes over here for the switch, but it also goes over here to this very key yoke mechanism with this pin on it, and there's 4 different plates that loop over or interact with this pin, and the innermost one, I believe, is the one that's of interest here. Let me get a little closer here. Okay, so here's probably the best close-up view I can get of this little clutch arm pivot mechanism. That's really quite key. If I reduce the spring tension, the innermost arm, which is right here on this pin out of the 4, it engages pretty good. If I add more spring tension by just pulling on this guy, it will kind of disengage from it. I guess I can't really see it very well from here, but I think it's been promoting some of my bouncing back and forth, because it'll click into that indent. I believe that's maybe addition, and then here it clicks in for subtraction, or forward, backwards, however you want to look at it, I guess. And then in neutral, the clutch arms are not engaged on the planetary, and it's the motor can spin, but it doesn't do anything. So basically, this spring tension here, go down here, this spring that's kind of out of focus right now. That spring, I think, was 2 tenths. Had too much tension. It always kept the start-stop switch closed, and it kept this arm from really engaging with this pin consistently, and just a bit of vibration and bouncing around would cause the thing to flop back and forth or not engage right and so forth. So it seems like adding this a little bit of a length with this home-brewed terminal seems to have helped quite a bit. It still jams and has all kinds of troubles and doesn't set right, but it's been an improvement. The next improvement I've made so far is this is called the 8-bank trip mechanism, and it deals, it would appear, with the carriage motion, and probably at the end of the carriage motion it probably stops it. Total speculation still on that, but if this spring tension isn't right, it will cause unpredictable canceling and tripping and then not tripping, and it's a pretty subtle motion here as to how it works. And there you go, it snapped. You can hear it actually snap that time. So it triggered one of the latches down here. There's like 2 or 3 different latches, and it triggers one of those latches, and it stops this arm motion from, or it triggers this arm motion to trigger something else. And the question here was this stud here. It screws into the plate here, and it clamps over this piece of sheet metal that acts as a mount point for this spring, which does something else. And this part here wouldn't be positioned quite right, and wouldn't put quite the right spring force on a spring that's lower down here, and I believe that's the spring that I had discovered earlier had fallen out. And so even after I put that spring in, things would behave unpredictably, and that's because this guy wasn't tightened right, and this little piece of sheet metal has a slot in it, and it can rotate back and forth a little bit, and then the tension on this spring and the tension back there on this other spring isn't quite right. And so with a little bit of experimentation, I figured out that if I pull this sheet metal part forward so that its C section of the part is as close to this screw stud as possible, and then tighten the screw stud, I seem to have achieved the right spring tensioning, and now the trip mechanism has the correct amount of travel, and it trips the little couple of those 1 or 2 other latches down here correctly. So that's kind of eliminated some unpredictability there as far as tripping. The machine still has lots of troubles, but at least that part of canceling for addition seems to work pretty well anymore. Subtraction, it still seems to be a problem. So anyhow, I was making some kind of progress.